This lesson is on the distributive property in combining like terms. So the first thing we're going to talk about today is like terms. The definition of a like term are terms that have the same variables to the same power. So if you look over here to the right where we have 3x minus 4 plus 6x, the first term, 3x, and the third term, 6x, both have the same variable, the variable being an x. Now, those x's also have the same power. Anytime a variable or a number doesn't have a power written, it is understood to be a 1. So this x has an understood power of 1, which means 3x and positive 6x are like terms. Negative 4 is not a like term because it does not have an x to a first power. Now in the second example, x squared plus 3x minus 4x squared, while all three terms have an x as a variable, the first and the third term both have a power of 2, which means x squared and negative 4x squared are like terms. 3x is not a like term. Now some things to remember about like terms are that a variable with no coefficient has an understood coefficient of 1. So what this means is up here where we saw x squared, this coefficient is understood to be a 1x squared. Whereas the coefficient of x is a 3, or the x squared here is a negative 4. The 1x squared has an understood 1, we just don't write that 1. Number 2, terms take the sign directly in front of the coefficient. So what that means is this 3x on this first example here has an understood positive. The 4 has a minus 4, so it becomes negative 4. And then this 6x is positive because of the plus in front. You always take the front sign. And then lastly, constants are like terms. So a constant is a number without a variable. So on the first example, minus 4, that negative 4 is a constant. So if there had been a number like a positive 2, negative 4 and positive 2 would have been like terms. All right, let's do a few examples. So number 1, now this has got quite a few terms. This is a good time to have colored pens or highlighters, but if you don't have those, you can always just create different shapes. So we're looking for our like terms. So here we have 6x squared. So I'm going to look and see if I have any other x squared. So I have an x, constant, and then notice I'm going to take the positive in front of it. So this is 6x squared plus 3x squared. So when I combine 6x squared plus 3x squared, we're going to get 9x squared. Alright, then I'm going to look for my next. So now I have negative 2x. I'm going to look for my next x's. So I have positive 5x, the constant and a constant. So that means I'm going to be combining together negative 2x plus 5x, which equals 3x. And then finally, I have my negative 3 and my positive 10, my constants. So I'm going to take it, I'm going to add negative 3 plus 10. Which equals 7. Now the last step is to put all of these together. So order doesn't matter, however in the future it will. So we tend to like to put the highest power first. So in this case 9x squared has the highest power. So I would write 9x squared. 3x is positive, so I'm going to put a plus 3x. And then 7 is positive, so plus 7. And that would be our final answer, 9x squared plus 3x plus 7. Now, if you get these out of order, it's not wrong as long as you have the same signs. They should all be positives, which means they should all have pluses in front of them, except for the very first term because we don't put a plus in front. All right, so now let's try number 2. So number 2, 7y minus 3 minus 2y minus 5y. So again, we're going to start going through. I start with my 7y. I look to see if there's any other y's. So I have minus 3 here, which is a constant, negative 2y, those have the same variables to the same power, and then negative 5y has the same variable to the same power. So we're going to take and do 7y minus 2y minus 5y, which when we combine these together, we end up with 0y. 7 minus 2 is 5, 5 minus 5 is 0. And then we have just this one constant, which is negative 3. So we don't have anything to add to it, which means we end up with 0y minus 3. However, we don't put 0y. That's silly. So instead of putting 0y, we just wouldn't put it at all. Our final answer would simply be negative 3. So there's only one term. So you can have variables fall out whenever you're simplifying these expressions. All right, number 3. 12xy minus 8x plus 3y plus a negative 4xy minus a negative 2y. Now, this problem has two things that are interesting. One, we have terms with two variables, x and y, and we have some double signs here. So we're going to go through here again, and I'm going to start with this 12xy. I tend to like to start at the beginning. I'm going to look to see, are there any other xy terms? And there are. We have this plus negative 4xy. Now, when we rewrite this, we're going to have 12xy. I don't like having these two signs, this plus and this minus. So I would just put minus 4xy. The plus there isn't really necessary. So 12xy minus 4xy is going to be 8xy. So then I go to the next term. I have this negative 8x. So I'm looking and I see that I have no other 8x's. So that means in my answer all I have is one negative 8x. And then finally I have this positive 3y and then this minus negative 2y. So when I combine those together, I'm going to have this 3y. When I have this minus a negative, remember that two negatives make a positive, so we're going to put plus 2y. So 3y plus 2y is 5y. So now all that's left is to put it all together. So I'm going to start with the 12xy. Again, actually, sorry, that should be 8xy. It doesn't matter the order of the terms, but since 8xy is positive, I don't need a plus. I am going to go ahead and tag on my negative 8x. I don't want to forget him. He's kind of important. This guy right here. We didn't have to add him to anything, but he still has to end up in our final answer. And then we have a positive 5y. So again, order does not matter. If you put 8xy plus 5y minus 8x, that's correct. Negative 8x plus 5y plus 8xy. Order doesn't matter here. Eventually it will, but at this point in time, it's not too much of a big deal. All right, last one for like terms is number 4. 5 plus m plus m. Now, this one may not look too difficult. Some of these other ones had a lot more terms in them, but this is one that people mess up quite often. And it's actually because of the variables, these m's here. And if you remember, what is the coefficient when there isn't one written in front? If you said 1, then you are correct. So this is a 1m and this is a 1m. If I were you, I would get into the habit of writing that in front when you have to combine things down. So when we're looking through here, we start with our constant, our 5. There are no other 5's, so we're going to leave that one alone. And then we have this positive 1m and positive 1m. So when we take and we combine 1m plus 1m, that equals 2m. And then all we need to do is add down the 5. Now I tend to put a constant last. Again, this is just a good habit to get into. It's not going to be a big deal if you put 5 plus 2m. But this is the simplified answer we would be looking for. You cannot add 2m plus 5. Okay, they're not like terms. Just like you can't add the 8x and the 8xy. Xy has a y. 8x doesn't have a y. They have to look the exact same variable to the exact same power.